Hey everyone, and welcome. Today we're diving into the hidden chemistry that, believe it or not, powers pretty much everything in our daily lives. We're talking about acids, bases, and salts. So let's get right into it.
So, to kick things off, let's start with a problem that I'm sure we've all had to deal with at some point. You know that feeling you've had a fantastic meal, maybe a little too fantastic, and now you're feeling that discomfort. All right, here's our puzzle. To get some relief from that acidic feeling, what do you reach for? Are you going to go for something sour like lemon juice or vinegar, or maybe something completely different like a solution of baking soda? Just think about it for a second. The answer isn't just some old home remedy. It's actually a core principle of chemistry. And here it is. This is the key, the entire solution to our little stomach puzzle. And honestly, so much of the chemistry all around us, it all comes down to this one single idea. Acids and bases have this amazing power to just cancel each other out. To really get how that works, we first need to know who the main players are. Okay, let's put on our chemical detective hats for a bit. Before we can solve the case of the upset stomach, we need to gather some clues and figure out how to identify our main suspects, acids and bases.
First up, we've got acids. And you already know these guys pretty well. They're what give lemons and vinegar that sharp, sour taste. In a chemistry lab, the classic surefire test for an acid is that it'll turn blue litmus paper red. A really simple but very effective clue. And on the other side, we have the bases. They're kind of the polar opposite in a lot of ways. They usually taste bitter and they feel slippery or soapy to the touch. And yeah, that baking soda solution from our question at the start, that's a classic base. Their telltale sign in the lab is turning red litmus paper blue.
So let's just put them side by side. This is really the crucial point. On one hand, you've got acids, sour taste, turn blue litmus red. And on the other hand, bases, bitter and soapy, turn red litmus blue. You see, they are perfect chemical opposites. Now, obviously, tasting unknown chemicals is a terrible idea. So how do scientists safely tell them apart? Well, they use special substances called indicators. Litmus is the famous one. It actually comes from lichen. But you probably have some indicators in your kitchen right now. Turmeric, for instance, turns this reddish-brown color if it touches a base, like a little bit of soap. Some indicators even change their smell, which is wild. Things like onion or vanilla can tell you if you've added an acid or a base. Okay, so we've identified our suspects. Now it's time for the main event. What happens when these two opposites, an acid and a base, finally meet? This, right here, is where the magic happens.
The whole concept is beautifully simple. They just cancel each other out. The effect of the acid is nullified by the base, and the effect of the base is nullified by the acid. The sourness and the bitterness just disappear. This incredible process is called neutralization, and it's the key that unlocks our whole puzzle. You can think of it like a simple recipe. Step 1, you take a base. Step 2, you add an acid. Step 3, they react. And what do you get? Two totally new things, a salt and good old water. So when your stomach has too much acid, you drink a mild base like baking soda to, you guessed it, neutralize that excess acid. And poof, relief, puzzle solved.
But here's the thing. It's not just about being an acid or a base. It's also about how acidic or how basic something is. There's a whole spectrum of strength out there, and thankfully we've got a special scale to measure it.
And it's called the pH scale. That P actually stands for potence, which is just the German word for power. It's really a measure of the power of hydrogen ions in a solution. It's a nice, simple scale that runs from 0 to 14, and it tells us exactly how strong an acid or a base is. The rules are super easy. A pH of 7, right in the middle, is perfectly neutral. Think pure water. Anything below 7 is acidic, and the lower that number gets, the stronger the acid. Anything above 7 is basic. You might also hear it called alkaline, and the higher the number, the stronger the base. Simple as that. And to put this into perspective, just look at these examples. Our own stomach acid is incredibly strong, way down there with a pH around 1 or 2. Pure water, like we said, is sitting right there in the middle at a perfect 7. And then a really strong base, like sodium hydroxide, goes all the way up to 14. This scale makes it so easy to see the huge differences in strength. And look, this isn't just some abstract concept for a lab. pH balance is critical for life itself. Our bodies have to stay in this super narrow pH range just to survive. Acid rain is so damaging because it lowers the pH of rivers and lakes. Even tooth decay is just a pH problem. It starts when the pH in your mouth drops too low.
And that's why toothpaste is basic. It's made specifically to neutralize that acid.
So this brings us full circle, back to that neutralization reaction. We've talked about how the acid and the base kind of disappear. But what are they replaced with? Well, we know one product is water. The other is something called a salt.
And it is so important to remember that when a chemist says salt, they are not just talking about the stuff you put on your fries. It's a massive class of chemical compounds, and every single one is created from a specific acid-base reaction, and each has its own unique uses.
Just take the most famous one of all, sodium chloride. You know it as table salt. It is so much more than a seasoning. It's, and I'm quoting the source material here, an important raw material for various materials of daily use.
I mean, just look at this. From that one simple salt, we can manufacture all of these crucial substances. Sodium hydroxide, which is used to make soap and paper, bleaching powder for cleaning, baking soda, not just for baking, but also for antacids, washing soda for your laundry. It's like a whole chemical family tree, and it all starts with common salt.
And honestly, this just scratches the surface of what they're used for. From baking bread to purifying our water, these products that come from neutralization are just woven into the very fabric of our modern world. Understanding that one simple reaction unlocks a whole universe of practical chemistry.
So the next time you use toothpaste or do a load of laundry, or even just season your food, I want you to remember that invisible dance of acids and bases. Neutralization isn't some boring concept in a textbook. It's a fundamental process that's happening all around you and even inside of you every single day. The only question left is, where are you going to spot it next?